Hi class, in this video we're going to be talking about adding and subtracting polynomials, and another way to word this is adding and subtracting like terms. So like terms are similar entities that we can add or subtract together, but they must be similar. So in our first example I have a plus a plus a. So let's represent this visually with some algebra tiles. One strip is just 1a, and if I have three of them, I'm just going to say my answer is going to be 3a. And there's also another way to look at this. So would you guys agree that x, it's a variable that can be any number? It's actually, I can also write that it can be equal to 1x. And the reason is because 1 times any number is still that number. So x can be equal to 1x. The same thing can be said for a. A can be equal to 1a. So if I write a 1 in front of every one of my a's, you can also think about this question this way. What's 1 plus 1 plus 1? 3. So I'm just going to have 3a. And if that doesn't help you, you can look at it visually. If I add 3 of these a strips together, how many do I have? 3 of them. So I just write 3a to represent how many I have. So in our next example, I have 7b plus b, or 7b plus 1b. So either I look at it visually, I have 7 b's together, I'm adding one more b to it, so now I should have 8b. Or you look at it and just say, for adding and subtracting like terms, if my entities are the same, meaning my variables are the same, so I have b and b, both of these are the same variables, I just add the number in front of them. So 7 is in front of b, 1 is in front of b, so I just do 7 plus 1, and I get 8. So I'm going to write my answer as 8b. Same idea for 4a plus 5a. If I have 4a here and then 5a here, if I add them together, I'm just going to get 9a. And here I have 10y minus 3y. I'm going to let green represent positive and red represent negative. So I have 3 negative y's. So these would cancel out with each other, and what I have left should be 7y. The other way to look at this is, what's 10 minus 3? 7. So I get 7y by that definition. But remember, I can only do this if the variable that I have are exactly the same. So here a is the same as every other variable, b is the same here as the other b, a is the same as a, and y is the same as y with respect to each term. So now let's go over some examples. Collecting like terms. Here it says simplify if possible. What is b plus b plus b? So for this one, remember, there are invisible ones in front of every variable if there's not another coefficient in there. So the coefficient in front of every variable that doesn't have a coefficient or looks like it doesn't is going to be 1. I just add these coefficients together. So 1 plus 1 plus 1, that's 3. So my answer is 3b. 4a plus 5a, 4 plus 5, that's going to be 9. And since these are the same variables, I just write 9a. Same variables here, b and b. Negative 3 plus a invisible 1 in front of here. So negative 3b plus 1b. So negative 3 plus 1 is going to be negative 2b. Now, b minus b. Remember, there's an invisible 1 in front of every b. So 1 minus 1 is actually going to be equal to 0. So I should have 0b. However, 0 times any number is still 0. So my final answer should just be 0. So b minus b is just 0. Just like if b was a number, let's say b was the number 5. 5 minus 5 is still 0. Hence, this works out. Now I have 10a minus 10. You see, this isn't possible. So I can't simplify this because they aren't like terms. I have an a here, and I don't have an a here at all. Hence, I say not possible to simplify because they are not like terms. Now for my final one, negative 8b minus b, remember there's an invisible 1 in front of the b here. So essentially I'm just doing negative 8 minus 1. This should just get me negative 9b. And if you're unsure how I'm getting negative 9 by computing negative 8 minus 1, you're going to have to do a review of your integers. Now, here are some more examples. These ones are slightly different. Notice now I have numbers in here. So what you want to do is you want to collect the like terms. So notice that 6y and 2y can be simplified together. So I'm just going to write here, I'm going to write this as 6y, and I'm going to add it to 2y. I'm just going to rewrite these in their order. And now I have negative 3 minus 5. So in this order, notice I can collect the terms that are the same. So 6y plus 2y is going to be 8y. But there's nothing wrong with me simplifying the numbers, because if I just have numbers which are constants, I can just compute the adding or subtracting with them to simplify them. So I have negative 3 minus 5. The answer should be negative 8. So now I have 8y minus 8. Can I simplify any further? No, I can't, because I don't have any more like terms. So my final answer would be 8y minus 8. Okay, let's try this other example. These are my like terms here. So let's rewrite the order. I have 10b minus 3b. And then I have negative 8 plus 2. So looking at my like terms, 10b minus 3b would be 7b. And then negative 8 plus 2, computing my integers here, this should be negative 6. Now I have 7b minus 6. Because there are no longer any like terms, I can't compute any further, so that's as simplified as I can get it to be. So my final answer is 7b minus 6. Looking at this other example here, let's rearrange to collect the like terms. So I have 3b plus 5b plus 2 plus 1. I'm just putting the same terms together and putting the numbers together that are constants. So 3b plus 5b is going to be 8b. And then 2 plus 1 is going to be 3. So my final answer should be 8b plus 3. Now for this final one here, I have 8b minus b. Remember, there is an invisible 1 in front of the variable if there's nothing there. So I would rearrange this as negative 8b minus b plus 6 minus 3. Now, negative 8b minus b is negative 8 minus 1, so I should have negative 9b. And then 6 minus 3 is going to be 3, so my final answer should be negative 9b plus 3. And now let's go over our last set of examples. Here I have y squared plus y squared. Now, I never taught you guys what happens when we have an exponent now. When you have an exponent, imagine this scenario. Let x equal to y squared. Now, recall, what is x plus x going to be if we collect the like terms? And there are invisible ones in front of my x. So in this case, I would just add 1 plus 1. So I would get 2x. However, if I let x be equal to y squared, well then, if I add these together, shouldn't I get something very similar? Shouldn't I just get 2y squared? And that's essentially the answer I'm getting. What most students are confused when they add these together, they tend to try to add the exponents as well. So they would write y to the power of 4 or 2y to the power of 4, but that wouldn't be the case. So in this case, just imagine an invisible negative 1 in front of every entity, and then just add them together. So 1 plus 1 is 2, so your final answer should just be 2y squared. Here I have 3y cubed plus 2y cubed. So I'm just adding the numbers in front together. So my final answer should be 5y cubed. Now I have y plus y cubed. I can't simplify this because although the y's are the same, if the exponents are different, I don't consider these like terms. So I'm going to write cannot simplify further because these are not like terms. And now for this last example, 2y squared minus 8y squared. So 2 minus 8 is going to be negative 6. So my final answer here is negative 6y squared.